In this video, I want to give you a quick introduction to Hypi's serverless platform, Fenrir. At the moment, you can get access to the examples that I will use in this video at github.com/hypi-universe/serverless-examples. Currently, Hypi supports Java, NodeJS, and Python runtimes for functions. Additional runtimes will become available shortly for languages like Ruby, Rust, and so on. In this video, we're going to focus on the ones that we do currently have, and I will start by showing you the Java examples. So each serverless function runtime has some requirements that are listed in the example README. For Java, you must have a class called main in this package, and that main class must have a method called invoke that accepts a map as its argument. The return type can be anything that's serializable to JSON using the Jackson framework. That's what the Java runtime uses. You can also return a completable future in case you perform some action that returns a future, and the runtime will automatically get the value out of that future and return it. Your function requires a Docker file, and that Docker file must basically copy your jar files, so your function and its dependencies, into home/hypi/fenrir/function. All the jar files that are in this directory will get added to the class path. Your invoke method will have access to an env key in the input parameter and an args key, and I'll explain shortly about what goes into those. In this example, we're going to go through the source that is in the example itself. It's relatively straightforward. As I mentioned, in this example, we're just returning a map, but you can return a completable future. Your input has access to env and args, which we're just printing here, and then you return whatever object you'd like that function to return. The important part for building and deploying the function is using the Hypi Java runtime, so Fenrir runtime Java and some version of that, and you must copy your jar files into the directory that I mentioned earlier. If you have additional dependencies, which most projects will do, you can add those in. The example POM file includes a plugin which will copy all of your Java dependencies into the lib directory. So if you uncomment this, that will allow you to deploy functions with whatever dependencies your function has. NodeJS is similar. It must have a file at home Hypi Fenrir function called package.json, and this is a normal Node.js package.json file, so you can put whatever dependencies your function needs into that package.json file. It must also have a file in the same function directory called main.js. Main.js must have an exports.main, and main is a function that has two parameters. The first parameter is the input object, and that input object has access again to env and args, and the second parameter is a callback, and I'll show you that example. So first parameter is input with env and args. Second parameter is a callback function that you use to return the results. So you call the callback, you pass the object that you would like to return as the result of the function, and if there's an error, you can return that as a second parameter instead. Python is again very similar. In this case, for Python, the only requirement is that you have home Hypi Fenrir function main.py, and this needs to have an async def called invoke, and its argument is a dictionary. This dictionary again has env and args as its inputs that you can extract. Now, if you have Python dependencies, just like in the other languages, you can either specify those in a requirements.txt file and have those installed into the image, or you can run pip install directly in the Docker file. For example, here you can run pip install, or if you have them in a requirements .txt file, you can run pip install on the requirements.txt file. Just like the other functions, your Docker file should start with a reference to the runtime, in this case for Python. And then once you've gotten your function written, regardless of which framework you've chosen, you now need to build that function and deploy it. The steps for building and deploying are the same regardless of which runtime you use. Step one is building the image and tagging it with the Hypi container registry. So Hypi container registry hcr.hypi.app / the name of your function : whatever version of your function you're building. Before you deploy the function, you must log in using the docker login command. So you use docker login hcr.hypi.app -u followed by Hypi. This username is always the same, so don't change it. And then for the password, you provide a token that you can get from the dashboard in your Hypi account. So under the developer hub, there's an authorization section. You copy this token and you can use that to log in to the container registry. Once you're logged in, and you only need to do the login once, you can then do docker push on the tag that you just created for your function, and that will deploy the function. After the function is deployed, you can use that function in your schema. In this case, I've already deployed the Java function example. The arguments to your function in the schema are what end up in the args map of the input for your function. You can have any arguments you want here of any type. So if you had a custom type as well, that could be used, and all of that will get passed into your function. Importantly, you need to reference the function using the fn directive and using the name of the function that you specified when you built the Java function. So when you did docker build, you specified my-fn. In my case, I specified my-java-fn, and that's the function name that you need to specify here. The version is the version that you specified as the tag for that image and subsequently pushed. If you'd like to pass environment variables into the function, you can do so by specifying the env key. This is optional, but if your function requires, for example, API keys or other information that you want to store on the backend and pass into your functions, you can do so using the env key. And once you're ready, you can query your function from GraphQL or REST by calling it using the name that you specified in the schema. Finally, the list of runtimes are available on Docker Hub. So you can see here the Python, NodeJS, and Java runtimes are currently available. And other runtimes will become available shortly as well for you to use. From the console, if you wanted to do this again, for example, the code. If you checked out the example, all of the code and examples that I just showed you on GitHub are available in here. All the Docker files for the examples for the different runtimes are available, and you can build any of those. In this case, I'm in the Java directory, and I can do docker build, and that will build the function. You could do this as well for NodeJS, and obviously the same thing for Python. Once you've built, you can push, so that will push the Java function, and you can push the Python function. All of that again allows you to reference the function in your schema using the fn directive by their name and their version. And that's it. That's all it takes to get a function deployed and hooked up in the new Hypi Fenrir runtime.